Okay, class, in this video we're going to find the distance from a point to the plane, point 368, I'm going to call it P, to the plane x minus 2y plus z equals 2. And we'll investigate other distances between objects in a plane as well as we go through this. But they're all going to sort of be the same as this example here. So, given a plane, you should be able to find a point on it. So we'll call my point P0. And we also know from the equation of the plane, we have the normal vector. It's embedded in there. We should be able to read it all. So, what we're going to do here, the plane distances to planes are always easy because of the normal vector. So, the distance between point P and the plane is supposed to be a perpendicular distance. And I could calculate the vector that goes from P0 to P, but that won't be a perpendicular vector. So what I do is I take that vector and I project it, do a scalar projection onto the normal plane, and that's going to be my distance. Okay? Now, keep in mind the scalar projection has a dot product in it. That could be positive or negative, so we take the absolute value when we're finished. Alright, so I'm going to take the plane, okay, so we're going to let x and y equal 0, and then z would be 2. So my point P0 then is 0, 0, 2. Pretty easy one, okay? And then we've already got the point P, which is 368. Let me copy it down here. Okay, so P0P would be 3 minus 0, 6 minus 0, and then 8 minus 2. So 366. Okay? From the equation of the plane, we can just look at the coefficients of the x, y, and z and see that the normal vector is 1, minus 2, 1. Okay? So we're going to do the scalar projection of P0P onto N. And remember that's P0P dotted with N over the magnitude of N. When you're doing these for a plane, the magnitude should always, in the bottom, should always be of the normal vector. If that's ever confusing. Okay, so we have our guys here. We'll just go ahead and do the dot product. So 3 times 1 minus 12, 2 times 6, plus 6. And then that's over the magnitude of 1 plus minus 2 squared is 4, plus another 1. So that's going to be negative 3 over root 6. Sorry. So my distance is 3 over root 6. Okay, the negative just means maybe my P0P is probably underneath the plane instead of above it, like it looks here. So how do you find other distances between objects and planes? So how do you find the distance between a line and a plane that it's parallel to? Well, it's pretty simple. You find a point on the line, and then you go back to this problem. Because it's the same question now, right? Okay, how would you find the distance between a plane and another parallel plane? Well, you take the top plane and you find a point on the plane, and it's back to this question. Okay? So anytime you're finding the distance to a plane, revert it back to a point in a plane, and you should be good to go.